It sounds like you're describing the Parker Solar Probe and its groundbreaking mission to study the Sun more closely than ever before. The Parker Solar Probe's accomplishments are truly mind-blowing. It has set multiple records, from approaching the Sun at a distance of just 6.1 million kilometers to achieving speeds of 690,000 kilometers per hour, making it the fastest human-made object ever built. What's even more remarkable is its ability to survive the extreme conditions near the Sun, such as intense radiation and temperatures that would normally melt most materials. Thanks to its specially designed heat shield and scientific instruments, the probe is making unprecedented measurements in the Sun's corona, the outer atmosphere that is much hotter than the Sun's surface. Scientists are particularly interested in the Sun's solar winds and the high temperatures of the corona, which remain a mystery. By studying these phenomena, we can improve our understanding of space weather and how it affects Earth. The Parker Solar Probe uses gravitational assists from Venus to tighten its orbit around the Sun, progressively getting closer with each flyby, ensuring it doesn't stay too long in the dangerous, scorching environment. Do you find the concept of exploring the Sun fascinating? It's amazing how technology is advancing to allow us to learn more about our own star. Weighing somewhere in the range of 501,000 kilograms, the spacecraft is launched nearly in an upward direction into space. Once they have arrived at Earth's orbit, the logical units are decoupled and sent on their way to their respective destinations. For route guidance, scientists depend on a mix of programmed and manual control methods, especially complex courses known as gravity assist maneuvers. These maneuvers utilize the gravity of planets like a sort of grandiose slingshot to speed up and keep the spacecraft on course without extra fuel. Each planet and moon presents its own challenges. Planets like Jupiter are incredibly hard to travel to due to the massive gravitational pull, which can put a lot of strain on the spacecraft's hardware or even destroy it. Mercury, the smallest planet, presents another challenge. Its proximity to the Sun means that spacecraft are drawn to the Sun's enormous gravity, requiring exact course estimations and controls. When investigating the Sun itself, researchers not only need to consider the extreme gravitational force but also the intense temperatures. Similar issues arise with Venus, which is also considered a scorching furnace. However, the Russians built several Venera probes during the 1970s and 80s that could withstand temperatures of over 450 degrees Celsius. NASA adopted a similar strategy when designing the Parker Solar Probe. The protective structure and flight paths are specifically designed to endure the extreme heat and radiation of the Sun. The probe is about 3 meters high and weighs just 685 kilograms, which makes it surprisingly light for a space probe. The compact design cleverly minimizes the surface area exposed to the Sun's lethal radiation while maximizing the stability of the housing. A fire-carbon composite material with a foam core is used as thermal protection. This thermal shield is around 11.4 centimeters thick and is sufficient to withstand temperatures of up to 1,377 degrees Celsius. On the side facing the Sun, the probe is extra thickly cushioned, while the delicate instruments remain on the shaded side. There, the engineers managed to maintain the accomplishment of keeping the sensitive sensors and the camera cooled to about 30 degrees Celsius. The carbon shield reflects half of the Sun's energy and also withstands the assault of high-energy particles from solar storms and cosmic radiation. Shields made of robust materials, such as aluminum, provide further strength. The protective shield is designed so that it always faces the Sun, regardless of the spacecraft's flight orientation. The most delicate instruments are well protected in a tightly shielded housing, and special coolants, along with heat exchangers, control the temperature at a constant 30 degrees Celsius. The question arises regarding how this probe conducts its energy supply so close to the Sun. The probe could utilize the extreme energy conditions outside to generate its own power. The main issue is that solar panels would burn up immediately if they were to face the Sun directly. To solve this, the scientists set the probe's solar panels so they would capture enough light to meet the probe's power needs while still being shielded from overheating. NASA engineers used an advanced water circulation system for cooling. The panels are designed so that only a small part of the surface is directly exposed to the Sun, while the rest remains folded. State-of-the-art technology fills the spacecraft, And now, let's investigate the probe's most interesting instruments. The Parker Solar Probe is equipped with 4 main instruments. One of the most intriguing ones is FIELDS, a high-accuracy magnetometer and electric field sensor. This device measures the electromagnetic fields in the solar corona and explores the complex interactions between the charged particles of the solar wind and the sun's magnetic fields. It helps us understand the physical processes that create and drive solar winds. Another highlight is WISPR, a wide-field camera system that provides stunning images of the solar corona. It can also describe plasma flows. This instrument provides incredible pictures of solar winds and coronal mass ejections. With these images, scientists can observe the formation of the particle streams directly in the corona for the first time. The solar wind electrons, alphas, and protons are also studied. The CLEAR instrument is a highly sensitive particle sensor that analyzes the structure and evolution of the solar wind. CLEAR can detect even the smallest particle flows of protons, electrons, and helium nuclei. The newly obtained data is crucial for understanding how these particles are accelerated and move through the solar system. With the ISPI, the Integrated Science Investigation of the Sun, NASA measures high-energy particles released during solar flares or coronal mass ejections. This instrument precisely tracks the directions of the flows and can thus compute their points of origin on the solar surface. These insights will enable scientists to gain a much better understanding of the processes that accelerate particles to extreme speeds and blow towards us as solar storms. Solar winds are common, but extreme eruptions can endanger our terrestrial infrastructure. These particles have the potential to cripple our power and communication systems. This risk from the sun was one of the reasons NASA built a solar probe. We need to understand the processes involved to protect our earthly power and energy supply systems. 6 years into its journey to the sun, the launch of the Parker Solar Probe on August 12, 2018, was an event. On board a powerful Delta IV Heavy rocket, the probe launched nearly vertically upward. After the successful launch, the Parker Solar Probe separated from the rocket and began its journey of over 6 years. The probe passed through the inner solar system and used Venus gravity to accelerate, gradually decreasing its orbit. These gravitational assists brought the probe closer and closer to the sun. In doing so, maintaining a balance between proximity and distance was essential. The sun attracts everything that approaches it due to its enormous gravity. However, objects don't typically fall into the sun. Instead, they fly by, as seen with many comets and asteroids. The probe, however, needed to not just pass by the sun but also approach it consistently and then swing back into a further orbit. Planning the course was an achievement of expertise. Scientists fine-tuned the trajectory, balancing the gravity of Venus and the sun. With each flyby, the planet's gravity slows the probe down slightly, making it follow a curved path closer to the sun. Like any mission, the Parker probe's journey was filled with tense moments. Many setbacks can occur along the way, and missions like this one always keep us on the edge of our seats. Subscribe to the feed now and be there for each new video.